or not. And I'll give us an example that we're simply going to use. So example says, first the law says, if you want to check whether something is commutative, the left hand side, which is A star B, must be the same as B star A. Now the star, guys, is simply the normal way that we just represent these operations. They can use any symbol that they want. Eh? The principles will still be the same. So someone would have said, this is the same as, this is the same as this. It's just the same. Whatever symbol that they use, whether it's a triangle, it's a star, it's a plus with a circle around it, it doesn't matter. The principle is the same. We just want to check whether the rearrangement will give us the same outcome. So I'll write an example here. Say example. So I'll use one of the old tutorial sheets. That's the guy we're going to be referring to. So I'm saying, given that A star B is equal to A plus B minus 2AB is star So if they leave the question open like this, there is no set mentioned. They just wrote it bluntly like this to say, is this commutative? Meaning you choose any real numbers to be your A and to be your B. And this is freestyle because you are giving yourself numbers. Because you don't use calculators during exams, it will be wise to give yourself small numbers because it will be easier to work with them. So we are saying, we'll let A be anything that we want, we'll let B be anything that we want. Then we'll say our solution. We'll say solution, so we'll say, remember, we are saying solution. So we'll prove this in two ways. So I'll show you the normal way, which is simply this. I'll show you method 1, so I'll write method 1. We check let, so you say let A be equal to 2, for instance, and let B be equal to, let's use 3. So what we want to check is whether 2 star 3 will be the same as 3 star 2. That's what we want to check using this rule that we have here, right? That's what we're interested in checking. You can choose any numbers that you want. I've just used B to be 3, A to be 3. You can use any numbers that you want. The outcome will still be the same. The conclusion will still be the same. So we're simply going to start with this part here. This is our left-hand side. So we'll say our left-hand side, which is simply 2 star 3 is equal to, according to the rule says what? The rule is simply A star B is equal to, let me write the rule first. A star B is equal to A plus B minus 2AB. Yeah, something like this. So here we have 2 star 3. What is A? A is 2, so we put a 2, we put a 3 minus 2, we have a 2, then we have a 3. This will give us a 5 minus a 12. We should get a negative 7. That's what we are getting to be our answer. So we're getting a negative 7. For the left hand side, we're getting a negative 7. So I hope you're able to follow, guys. Wherever you're watching this video from, A is 2. Wherever there is A in the expression, we simply replace by 2. Wherever there is B, we replace by 3. So we are saying, here there's a 3, here there's a 3. We follow BODMAS. We first of all add this is a 5. This will be a 4 times that, that's a 12. 5 minus 12 to give us a negative 7. This is the left hand side. We have done it. So we come back. We now solve the right hand side. This part here, this is our right hand side. So our right hand side will still be the same. Remember the rule is still going to be the same. What has changed are the figures, right? So you have AB. What has changed the arrangement? Our A is now 3 and our B is now 2. So we have 3 star 2. This will be 3 plus 2 minus 2, 3 and the 2. This will still be 5 minus 12 to still give us negative what? Negative 7. Luckily for us, in this case, we can say, we put up a conclusion, we are getting the same outcome still. So we can say, since A star B is the same as B star A, star is commutative. Because we got the same answer, so say the star is simply commutative. If they were different, we would have said star is not commutative. That would have been our conclusion. So this is basically how we prove it. And I said this is method what? Method 1. You use numbers to check whether it's commutative or not. That's what you basically do. Then method 2 is a general way. So the general way follows the rules. So I'll say method 2. Remember what you had initially. We're trying to check this. This is what we want to check. Whether this will be the same as that. So according to this, with the law that you have been given, it's simply 2AB. According to this, it's simply going to be this, 2BA. This is basically what you are going to have. Right? We want to check if this is equal to that. So meaning we have this. Check the rearrangement. Here A comes first, then B. Here B comes first, then A. You have this arrangement. You can gather the like terms. We're simply saying this A and this A will cancel. This B and this B will cancel. You just remain with AB. This will simply be BA. The negative 2's can cancel. We simply have AB is equal to BA. This is simply the same as 1 to 1. 1 is equal to 1. This is true, right? 1 is equal to 1. So meaning we've proved to say the operation is what is commutative. Because despite us rearranging them, we're still going to get the same outcome. The left hand side is equal to the right hand side. That's how we check that an operation is commutative as well. Yeah, so this is just method 2, but I would advise for you to use the first method because it's easy using numbers. Yeah, and if you get your answers to be different when you use numbers, it simply means the operation is not commutative. So you have to put not commutative. The conclusion doesn't always have to be that the operation is commutative. Sometimes it can come out to fail to be commutative. So that's what we basically have. Thank you so much for your time. In the next video, we'll talk about associativity.